Okay, so we're going to get started. Does anybody have any questions before I start solving problems? Best way to study for a test is, of course, to solve lots of problems. The sample final, something you should actually sit down with that like a final. Like, don't turn off your phone. You can print out the table of annihilators if you want, but don't let distractions bother you. Try to be very test-like. So treat it, go to a quiet place, treat it like it's actually a real test that you've got to study for. That'll help you, I think, to feel more comfortable on Monday as well, rather than kind of just doing it relaxed, right? Because that's not really duplicating the test environment that much. But anyway, so lots of practice problems. So I'm going to give you guys some problems that we can practice on off of these review problems here. So let's start with the first one. We'll just go right in order here, at least at the beginning. So suppose I ask you to solve this problem here. So x prime equals negative x plus 2y plus 54t e to the 3t, and y prime equals negative 2x plus 4y plus 9 e to the 3t. So I give you that. Okay? So help me out. What's your first reaction? It looks like a linear system. It's obviously more than one equation. There's how many unknown functions? Two unknown functions. So and also there are derivatives involved. So we must be talking about linear systems of differential equations. So it's important that you just take the time to make sure you understand where in the semester does a certain problem fall, because the final is going to cover a lot more stuff now. So it definitely falls under the stuff we covered lately. So can I rewrite this in a different form?
Yeah.
How would you want me to do? Okay, so we can make that matrix, right? And then there's actually, yeah, there's a non-homogeneous term here, right? So the non-homogeneous term would be 54t e to the 3t and 9 e to the 3t. That's the so-called b vector. And all of this is equal to the x prime vector. Notice I'm putting an arrow on anything that's a vector as to distinguish it from these scalar functions up here. So this x prime right here is not the same as that x prime. Okay, so that's an important thing to keep in mind. Okay, so this is a problem that we're going to solve how? Yeah, the large method is called variation of parameters for linear systems. So we're going to use variation of parameters for linear systems. And that's in what section of the book? That's what we just covered recently, right, exactly. So 7.6, I pretty much guarantee you I'm going to ask you one of these problems on the test. So may as well get it down. So it involves a lot of steps, right? There's a lot we have to do. So what's the first thing we would have to do here? Okay, good. So for step one is where you're trying to find a complementary function. So you're going to ignore the b vector at first, and you're just going to focus on x prime equals ax. So this is the problem, and we need the eigenvalues of a in order to do this. So we take the determinant of negative 1 minus lambda, 2, negative 2, and 4 minus lambda. For a 2 by 2 matrix, of course, it's always going to be possible to find your lambdas. So this is equal to negative 1 minus lambda times 4 minus lambda, and then plus 4. And if we simplify that, we're going to get lambda squared minus 3 lambda, I believe? Yeah. Okay. So what are my lambdas here?
0 and 3.
Okay, good. So lambda is 0 and lambda is 3. These are the lambdas. So it's not defective, right? It's a very nice matrix, 2 distinct real eigenvalues. So it's not a defective matrix. One of the problems on your homework assignment, it was a defective matrix, and you actually had a slightly messier situation. But this one is not too bad. So once we have our eigenvalues, what do we do next? Yeah, we have to get the corresponding eigenvectors. Getting these eigenvalues is absolutely crucial, right? I mean, you have to be able to get that right. You've already seen that on the third midterm, right? If you don't get the lambdas, the whole rest of the problem becomes very difficult. So be careful to get to this point correctly. This is only a 2 by 2 matrix, of course, but even the 3 by 3 matrices, we've seen several of those. You need to be able to find the eigenvalues, usually by cofactor expansion. Right, okay. So for lambda equals 0, we're just going to find the null space of the actual original matrix. We don't actually have to subtract anything. So it's just -1 and 2, -2 and 4. And those rows have to be multiples of each other. If they aren't, it means you probably made a mistake. So, so I can just cross off either row. And then by eyeballing it, at this point, a lot of us are getting pretty good at just eyeballing it to find a vector that's in the null space. What would be a good vector to use here?
2 and 1.
Right, 2 and 1. Okay, great. So that means my first solution, which I'll call x1 of t, would be e to the 0t times 2, 1. So just 2, 1. Okay. And then my second eigenvalue is lambda equals 3. So we're going to subtract 3 from the main diagonal of the matrix A. So if we subtract 3 from the main diagonal, that's the 2 by 2 matrix that we get. Once again, the two rows have to be multiples of each other, so we cross off a row. I usually choose to cross off the row that has the bigger numbers in it, but it doesn't really matter. Okay, and what would be a nice choice of a vector here that's going to be killed by that row?
1, 2.
Yeah, so 1 and 2, right? 1 and 2. Okay, good. So I get a second solution now. Second solution is e to the 3t times 1 and 2. Okay? Great. So you can now take these two solutions, and write down the complementary function. Right? So we're just about done with step 1. So the complementary function, you guys remember, is just c1 times the first solution, which was 2, 1, plus c2 e to the 3t times the second solution, which is 1, 2. So there is your complementary function. That's step 1. So far, so good? Any questions? Now, one of the reasons I'm choosing to do one of these problems is this reviews a lot of other stuff along the way, right? We're having to do a lot of things here. Okay. Another thing that we can already do at this point, based on what we have up here, is what else can we write down at this point that we are going to need in the next step? The capital X matrix. Remember, this is called the fundamental matrix. What that is it's really just a matrix whose columns are the solutions that you found in the first step. So it's not a bad idea. Just go ahead. We can write that down right now. Okay? So the first column is just 2 and 1. Of course, you can put them in either order that you want here, but I'm just going to make this choice for now. And then the second column will be e to the 3t and 2e to the 3t. Okay? Does that look all right? Okay, so that's my fundamental matrix. And that matrix will always be invertible. Do we need the inverse of the matrix? We are going to need the inverse of that matrix in the next step. So I'm going to go ahead and find it right now, just so we have it already taken care of. The inverse of this matrix, this is just a 2 by 2. So what we can do is calculate the determinant of it. What is the determinant of that matrix? 3e to the 3t, right? And that's what you divide by. So you divide by the determinant out in front. And then on the homework, a few people mix this up a little bit, so just make sure you know how to do this. You swap the diagonal numbers. So the 2e to the 3t goes in the upper left corner, the 2 goes in the bottom right corner, and the other two numbers pick up minus signs. So a -1 there and a minus e to the 3t. It's going to kind of look like that. Okay, so that's my x inverse. So far so good? Okay, so now let's start talking about the second step. In the second step, we have to find a particular solution to the linear system. So to just remind you of what are the important things you have to remember here, you have to remember the choice for the particular solution is going to look like this. Capital X times U. I don't need to put the T there. So it's just capital X times U. And you have to remember the formula for U. Basically, you have to take the inverse of X, multiply it by the B vector. This is where the B vector that we were given over there is going to come into it. And we have to integrate that. Okay? So these two equations are kind of important to keep track of. Okay, so far so good? Any questions? Okay. So we'll really have to figure out the U first. That's what we need to do next. So in order to do that, I want to take the inverse of X, and I need to multiply it by B, which is over here. Okay, so maybe at this point I can start. I'm going to try to use these two boards mostly. Here's the B, I need that. Okay, so X inverse times B, we're going to need to calculate this thing. So it's what? 1 over 3e to the 3t times 2e to the 3t and negative e to the 3t, and we have negative 1 and 2, multiplied by 54t e to the 3t and 9 e to the 3t. Okay. So let's see what we get. I'm going to leave the 1 over 3 e to the 3t outside for a minute, okay? And just start multiplying this stuff inside together. So we're going to get a vector here. Oops, I might need a little bit more room than that. So 2 times 54 is 108. And then there's a t and an e to the 6t, right? Because e to the 3t times e to the 3t is e to the 6t. And then minus this one times this one is 9 e to the 6t. So far so good? Alright, now on the bottom row we're going to have negative 54 t e to the 3t plus 18 e to the 3t. At this point, it will help us and it will be simpler if we if we pull this denominator into every single term. Because see, there's a factor of 3 in all of these numbers, so we can cut down the scalars and also cut down the exponentials. Okay, so for example, 108, when I divide it by 3, it gives me 36. So this becomes just 36t, and what is the exponential going to be? Yeah, you have e to the 6t being divided into e to the 3t, so you're going to get e to the 3t. And then 9 divided by 3, of course, is just 3, e to the 3t. Okay? On the bottom line, 54 divided by 3 is 18, so we're going to get negative 18t. And notice the exponentials cancel. E to the 3t divided by e to the 3t. Here, 18 divided by 3 is 6, so we're just going to get plus 6. Okay, we have to integrate that now. Okay? Everybody so far so good? Okay? So we have to do this integral, and what I might suggest here, this one's the only one that's going to be annoying. So you notice that there's an integration of e to the 3t times t here. Let's just do this first on the side, and then we'll feed it into the integration once we've done it. And I'm not going to put the 36 in there yet. I just want to get the core integral here. Everybody sees what I'm doing, right? See, I have to integrate. To get u, I'm going to need to integrate that thing there. Okay, so I can do this one by doing integration by parts. So you guys have seen this in 150b. Basically, u is going to equal t, and dv would be e to the 3t. Okay? So then the derivative of u, which is du, becomes what? dt. And v becomes what? 1/3 e to the 3t, right? And we don't need any plus c on anything for what we're doing right now. Okay, so then u times v is 1/3 t e to the 3t, and we have to subtract the integral of v du, which is 1/3 e to the 3t dt. Like that. Okay, and again, no plus c is needed. When we come down here to the below this is where I did my integration by parts variables. So I'm going to get 1/3 t e to the 3t minus, let's see what we have here. What am I going to get when I anti-differentiate this part? 1/9 of e to the 3t. Okay, good. So at least we got that integral done ahead of time. Everybody's okay with that? Perfect? Okay, good. So then I can come back and figure out, let's start working on what u is. U is the integral of x inverse times b. So I'm going to integrate, here's x inverse times b, right? So I'm going to integrate x inverse times b, and that means I'm going to integrate both slots, right, or all of these terms. So we already did the integral of t e to the t, we just need to scale it by 36. So if I scale this by 36, if I multiply it through by 36, right, I'll end up with what? 12t e to the 3t minus 4 e to the 3t. So the numbers actually are not that bad. And then what is an antiderivative of 3 e to the 3t? Pretty easy one, just e to the 3t, right? And that's the integral of 3 e to the 3t, just by u substitution if you want. Okay, and then we also have to integrate the bottom line, so can somebody other than Irwin tell me what the antiderivative of the bottom line is going to be? Minus 9t squared plus 6t. Very good. Okay, this can be simplified slightly right here. I can put those two together. Other than that, we pretty much have what u is. So now let's try and write down the particular solution. Okay, everybody still with me? People a lot of times don't like this problem because it takes so long. There's like a lot of steps, but it's really very procedural. If you have the process down, you don't have to actually think that hard through the steps. It kind of follows along naturally. So the particular solution now is just x times u. So x, we already have that, it's right here. It's 2 e to the 3t, and then 1 and 2 e to the 3t. So that's x. And I need to multiply that by u. Here's what u is. Let me write down u after I'm going to simplify that top term to be minus 5 e to the 3t. And then on the bottom, it's just negative 9t squared plus 6t. You have to be a little careful here because it kind of almost looks, this is a 2 by 2 matrix. And this looks just as wide as the 2 by 2 matrix, but this thing on the right is actually just a single column. Right, so just be careful about that. You have to recognize that that's what's going on. So I'm going to work this out just with a usual matrix multiplication. So it's going to be 2 times 12t e to the 3t minus 5 e to the 3t plus e to the 3t times negative 9t squared plus 6t. So I'm just multiplying it out. So this times this plus this times this. Alright? And on the bottom line, we're going to have 1 times the top entry, which was 12t e to the 3t, minus 5 e to the 3t, and then plus 2 e to the 3t times negative 9t squared plus 6t. There's your particular solution. You could decide you want to be fancy and factor things. I think every single term has e to the 3t in it. For example, you could like pull that out in front. I don't really require you to do that. You could choose to do that, and then you can also combine some terms together, I think. It's like here's a 24t, and here's a 6t. You can put those together, but it's not necessary. This is okay with me. Okay, so then once we have the particular solution, then what's my final answer going to be? this part plus this part, right? Okay, good. So it's just, I won't write it out. If you want to look it up in the solutions later on, you can. But you basically just have to piece those last two terms together. Yeah, and I don't need to always see all of that work. Okay, you guys can just go ahead and, as long as it's clear, like notice I'm putting things in boxes, right? So, because I'm referring back to them, it's very helpful to do that. Okay, are there any questions on that? This problem reviews how to multiply matrices. It reviews how to find the inverse of a 2x2 matrix. It reviews eigenvalues and eigenvectors, finding null spaces, which means solving systems of equations. And tell me something this doesn't review. Right? So it's just about everything. He even had to do a little bit of an integration right here. So took 20 minutes to work that out, but it was never really that hard at any given point. As long as you know these formulas here, should be pretty good to go. All right. Okay. Everybody okay so far? Okay. Let's tackle some other things. Again, I'm not going in the same order as the problems. Well, here, this problem was actually the first one in the packet. But I want to jump around a little bit so that if I do run out of time today before I get through everything, I will at least feel like I have touched on a lot of stuff. Okay. And again, you know, you're not necessarily going to walk out of the review feeling like, oh, I know everything, I'm ready for the test, right? The idea is you're going to walk out of here saying, oh, I know what I need to focus on, right? And then you still have 2 days to go home and look the stuff over. So, okay, so here's the second one I'm going to cover. I'm going to let S be the set 2A minus B, B, negative 3B, and 0, such that A and B are elements of the real numbers. So part A is going to say, show S is a subspace of M2 of R. We're going back to some of the sort of classic linear algebra stuff here. If I ask you to show that something is a subspace, do you remember what that entails? You have to show closure under addition and closure under scalar multiplication, and you really do have to spend a little effort to write things out as sentences a little bit. So we have to do that. So closure under addition, that's basically the first axiom of a vector space. We have to check that. So how do we start that off?
Another form of that.
Say again?
You find another form, like say 2C minus B.
Okay, so write down two matrices. Here's one matrix, but you need two for closure under addition, you need two matrices that have that form. So you're going to need to use different letters for the second matrix because they aren't necessarily identical matrices. Okay, so what you could do is you could say something like, let 2A minus B, and then B, and then negative 3B, and 0, comma, and then 2C minus D, and negative 3D at 0. So you start off this way, and just say that, let that be in S. So you have to write that sentence down. If you just start putting down matrices and there's no words to go with it, you're going to be not getting full points because this is partly an explanation that you're doing right now. Anything that's kind of like a proof really should have an explanation with it. So write that sentence down to get things started, and then what you need to do is add them together. Now if you want, you could also have called this capital A and capital B if you wanted. That would be fine. Let capital A and capital B be in S, and then you'd have to say, well, this is what A is and this is what B is. That's fine. Okay, you don't have to do that, but you can. And then you just have to add these together. So 2A minus B, negative 3B, and 0. We add that to 2C minus D, and negative 3D, and 0. And we just want to check, when we add those together, we're going to get 2A minus B plus 2C minus D, and then D, and then negative 3B minus 3D, and 0. Just slot by slot, right? Okay, just slot by slot. And what would you suggest that I do next?
Add the B to the top right entry.
Oh, I'm sorry, I did that, that's a mistake. Yeah, that should have been B plus D, sorry. Yeah, B plus D there in the top right entry. Okay, so what should I do next?
Start grouping the twos and then
Would it be okay for me to just say element of S, I'm done?
no.
See, if you just do that right now, then you're not really convincing me that it's in S, right? If it's going to be in S, it has to be in this form, which means each entry has to match this form. So it should be 2 times something minus something. And that's not what I have right here. So you really need another line, I'll just squeeze it up here, I think, where you try to rewrite it to be in a nice form. So, what did you suggest that I group together now?
The twos and
So the 2 is multiplied by what?
the
A plus C, right? And then minus what?
B plus C plus B.
Yeah, and put parentheses around that when you group that together, right? So you're going to need to do that. Okay. And then the top right corner is actually fine, right? The B plus D, that's matching what you subtracted in the upper left corner, so you don't really need to change it, you just need to write it down. Okay? And what about on the bottom line? Good, take out the -3 so that you can put B plus D together, and then we have 0. And now you can write element of S. Okay? Now that's perfectly fine. All right. So far so good? Then the second part is what?
Scalar multiplication.
Right, scalar multiplication. And how do we start that one off?
When A B is above and K B all numbers.
Okay, so we'll take the same matrix that we had before. B as above, or I guess since I'm writing out the whole matrix, I'll just say let it be an element of S. And then our scalar, I usually use a K for that, so that's an element of the real numbers. Okay, so we write that down, and then what do we need to calculate? Exactly, K times the matrix. So K times the matrix is, try to show all of your steps, guys, because sometimes it's easy to jump ahead and say, oh, I see what's going to happen. I really want to see it all worked out if possible. So this is going to be K times 2A minus B, KB, negative 3KB, and 0. Okay, now what should I do? You factor out the K, you're heading back in the direction we came from. And that's what a lot of people do. They never quite prove what they're supposed to prove. What you need to do here is make sure you rewrite this in this form again. The upper left corner has to be 2 times something minus something. So you want to actually pull the 2 out, because that needs to be in front, and it's multiplied by Ka, so we'll just put that like that, and then minus Kb is the part that doesn't have the 2 on it. Okay, so you're doing this algebra. The algebra that we're doing right here in this step is not optional. You have to have this step in there. Kb, of course, is just fine as is, and then this is just -3 times Kb, and then we have a 0 there. Okay, so this is how it's going to look. And now you have something, this is K times the matrix. It does have the right form, so I can see that, so it's an element of S. Okay? So that is, that shows that that is a subspace. Yes?
Couldn't we have done it the other way where we can bust out the variables? Did you like make vectors? Kind of like a cheap trick where you like make vectors?
So let's go on to part B of the problem, and then I'll come back to your point.
Okay.
Yeah, part B of this question, now that it's a subspace, it has a basis and a dimension. Right, you can always ask those questions. So there's a part B here, which is find a basis and dimension of S.